Hey sixth graders, we are on lesson 1.4 part 2, and as a quick recap, in lesson 1.4 part 1 we used our Jolly Ranchers. So we had whole Jolly Ranchers, which represented our rock formations. We put them in those cups and we shook them up, and we went and we modeled the process of weathering and ended up with a bunch of sediment. So once we have this sediment, we are going to try to model what happens next with our sediment as it goes through the process here to become a sedimentary rock. So we are sticking another cup on top of it, and then we are going to add a book and add lots of pressure on top of it in order to model what would happen over time, over millions of years, as those rocks get pushed down and have weight on top of them, and then the minerals mix in with them, and then we get a sedimentary rock. So let's look and see what we can, So we can't really watch this model of compaction and segmentation in real time, even though we're kind of modeling it here with these cups. It really isn't going to be a true model, but it's a good option for us to look at, so we can kind of have this hands-on experience with them. But however, we can watch what happens when magma cools and forms a rock in real time. So we are going to watch a quick little video where we get to see that happening in real time here. And there's no music, so you won't catch me dancing this time, sorry. But as you can see on the edges of this rock here, it is starting to get that dark color, so we can see that it's cooling. And this part right here and over on this other side, those are parts of magma that are already cooled. So we have the flowing magma through the middle, and then we have those cooling parts, which are going to be igneous rocks. So we can see on this left side that this image shows what some basalt looks like as it is at the Earth's surface. So when magma cools at the Earth's surface. And over here we can see what this looks like as it's cooling, when it's kind of solid enough for us to stand on, but it's not completely solid. So you can see here she's kind of poking at that, and it's a little bit of a soft solid still underneath that. So the process of cooling is transforming magma into a solid rock, and it happens when the magma cools off, and it happens, so that's something that we can watch in real time. When magma cools underground, it can take a really, really long time for it to cool, so we can't look at that as quite as frequently here. An igneous rock is a rock that's formed with magma cools and becomes solid. And I'm just going to review the key concepts that we've learned so far in this unit before you get into your practice. So the first is that rocks can form in different ways, and this causes them to be different types of rocks. So depending on how the rock forms, whether it's through pressure, compaction, cementation, or if it's from the magma cooling, we get two different kinds of rocks. We get a sedimentary rock or an igneous rock. When the sediment is compacted and cemented together, it forms a sedimentary rock. And when magma cools, it hardens to form an igneous rock. So we are going to keep looking at these characteristics, and so you are going to look at a characteristic chart in your assignment today, and you're going to kind of look at different rocks, the 4 different hand samples that we had, and make these observations with those hand samples and try to identify, do you think that the rock is igneous or do you think that the rock is sedimentary? Then once you've done that, you can record all of those on your sheet, and then you will be doing a little bit of reflecting. Remember that we, as geologists, are using these rock samples to really help us better understand how rocks are formed, and looking at those Great Plains and the Rocky Mountains, and we will be continuing this investigation here. So you should open up the next assignment, grab some hand samples, and begin exploring. Remember, today is a great day to learn. Happy learning!